This is an A-star level video that goes through parametric equations, and also there's a bit of binomial expansion. Yeah, two binomial expansion, that is. So let's break this down. Right now we're given x and y in terms of a different variable t, a parameter t. We want to find dy dx though. What we're able to find is dy by dt by differentiating the right hand side with respect to t, and we're able to find dx by dt by differentiating the x equation with respect to t. So let's break those down first. First of all, we're going to put y in a format where it's easier to differentiate. So I'm going to write as 1 plus t all to the power of 3 halves. The reason we're able to do that is because we have 1 plus t cubed inside of a square root. So that's essentially all being applied to a power of a half. 3 times a half is 3 over 2, which is why we can replace the power with 3 over 2. When we're differentiating that with respect to t, we can actually, I think the easiest way to do this is using the chain rule. There's a bit of a secret though that I'll show you to speed up the chain rule for the sake of this question. That secret is you multiply the power to the coefficient here, which is just 1. 3 over 2 times 1 is 3 over 2. You then differentiate everything inside the bracket with respect to t, which will differentiate to 1. And then you write out the bracket one more time, but you subtract from the power a power of 1. So 3 over 2 take away 1 is 1 over 2. 3 over 2 times 1 is 3 halves, so this can be written out as 3 over 2 and then in a bracket 1 plus t all to the power of a half. Let's apply that same logic to find dx by dt. To start with, I'm going to write x in a format where it's easier to differentiate, just like we did before. So I'm going to write minus to represent the minus outside of the square root, and then I'm going to write this out as 1 minus t. So right now it's 1 minus t cubed, and then all of that square rooted. The square root, like I mentioned, is the same as applying a power of a half. Whenever there's a power inside and outside the bracket, you can multiply those powers together, which is why this power can be replaced with 3 over 2. We're going to differentiate this in a very similar way. So just a reminder, we're going to multiply the coefficient by the power, minus 3 over 2, that would become. We're then going to differentiate everything inside the bracket. So 1 minus t will differentiate to minus 1. And then we rewrite out the bracket 1 minus t, but then we subtract 1 from the power. Now, minus 3 over 2 times minus 1 is positive 3 over 2. So this becomes 3 over 2, and then in brackets 1 minus t all to the power of a half. Now that we've got dy dt and dx by dt, we need to think about how they can combine to give dy by dx. So let's do that. Actually, I'm just going to increase the thickness of the pen. So if we multiply them together, dy by dt and dx by dt, what you'll see is, well, that doesn't really make sense. The dt's will multiply to give dt squared. These will multiply to give dy dx. If we instead multiply by dt by dx, what you'll see now is the horizontal variables dt will cancel, not horizontal, diagonal variables dt will cancel out, leaving you with dy by dx. Now dy by dt, we already have that. That's that's 3 over 2 and then 1 plus t all to the power of a half. But we want to multiply onto it dt by dx. Right now we have dx by dt. To get dt by dx, that's essentially the reciprocal of dx by dt. So if we do the reciprocal of everything here, so we flip over the fraction, so it becomes 2 over 3. And not only that, but this variable here, 1 minus t to the half, goes to the denominator now. Then we can multiply that onto dy by dt, which we've already written out. So 2 over 3, and then on the denominator, 1 minus t all to the power of a half. Now 3 over 2 times 2 over 3 is just 1. So that's going to be equal to 1 plus t to the power of a half on the numerator, all divided by 1 minus t to the power of a half on the denominator. How do we show that this can be written in this format? Well, if we compare what we have to what we want to get to, on the numerator there's just 1 plus t. We have 1 plus t to the half. So if we multiply top and bottom by 1 plus t to the half, that will make it so that the numerator becomes just 1 plus t. So I'm going to erase all of this now, actually, just so we have space to do that. And like I mentioned, we're going to specifically multiply the numerator by 1 plus t to the half so that it matches the numerator in the question. Whatever you do to the top of a fraction, you have to also apply that to the bottom of a fraction. So I'm going to multiply the bottom by 1 plus t to the half. A half plus a half is 1, so that becomes a power of 1. So 1 plus t all to the power of 1, or just 1 plus t. And then divided by, now here's where you have to really think outside the box. If we have the square root of a multiplied by the square root of b, that can just be written out as square root of ab because of how we know to deal with surds. In that same way, we can write this out as square root of 1 minus t multiplied by square root of 1 plus t, so that becomes the square root of 1 minus t, 1 plus t. That's just the difference of two squares actually. 1 times 1 is, sorry, there should be a plus there. 1 times 1 is 1, minus t times t is minus t squared. So inside the bracket, you can just put 1 minus t squared. And what you can now see is that that matches up with the dy dx on the first part of the question, right? So that's everything that you need to do for that. Now that we've done that, I'm just going to erase that just so we have space for part B of the question. Part 2 of the question tells you to expand out up to the term t to the 4. Now for this, we're going to use a binomial expansion, and there is a formula that's given to you in an exam. I'm just going to very quickly write that out, and I'm going to go through how we use this formula and not the other one for binomial expansion. Just bear with me one moment. So a squared plus n lots of n minus 1 over 3 factorial a cubed, so on and so forth. We're also going to go through how many terms you want to include. First of all, dy dx, in order to expand it out using the binomial expansion, I'm going to put into a format where it's easy to deal with. I'm going to write this out as 1 plus t, and then in brackets, 1 minus t squared, all to the power of a half. Sorry, minus a half, because the minus represents it being brought up from the denominator onto the numerator. Now this is just a power of 1, this bracket, so we don't really need to do binomial expansion on that. However, the second bracket is where we have to. Now, first of all, if your power is not a positive integer, that's where you use this equation here. So here n is not a positive integer, so we use this equation. Let's do this in a different color, just to change things up a little bit. In this case, a is being replaced with minus t squared, and n is the power, which is minus a half. Putting it into this expression, we have that this here can be expanded out into 1 plus na, which is minus a half multiplied by minus t squared, and then plus n, which is minus a half, multiplied by n minus 1, which is minus 3 halves, all divided by 2 factorial. 2 factorial, it just means, well, any factorial, like for example 4 factorial is just 4 times 3 times 2 times 1. You just keep multiplying the numbers in descending order until you get to 1. In this case, it's just 2 times 1, which is 2. So that's going to be multiplying by 1 over 2 if you're dividing by 2 factorial. And then a bracket of a squared, which is minus t squared, all squared. What you may have noticed is you actually don't need to go further. It's only looking up to the t to the power 4th term, which is what this will give you. You don't need to go any further. Expanding this out, minus a half times minus t squared is plus a half t squared. Minus a half times minus 3 halves is, well, 3 over 4. 3 over 4 times a half is 3 over 8. And so that will become 3 over 8 t to the power of 4 because of minus t squared times minus t squared equaling 2 to the power of 4. Great. We can now write out this expression here as 1 plus t, and then in brackets, everything that we just introduced, 1 plus a half t squared plus 3 over 8 t to the power of 4 plus dot dot dot. When expanding this out, this will give you all the terms up to t to the power of 4. So 1 times 1 is 1. 1 times a half t squared is just a half t squared. 1 times 3 over 8 t to the power of 4 is just 3 over 8 t to the power of 4. T times 1 is t. T times a half t squared is a half t cubed. And you may have realized, but you don't need to do t times 3 over 8 t to the power of 4, because that'll get you the 5th power of t, which we're not really interested in. So yeah, that's everything that we write here. It does say write as ascending powers of t, so you want to sort of rearrange it, so you put the 0th power of t, and then the 1st power of t, and then the 2nd power of t, and then the 3rd power of t, so on and so forth until the last one. Lastly, to estimate the gradient when t equals 0.5, well, dy dx is what gets you the gradient, and because we're dealing with an estimate, it wants you to use the expansion that you found and put t equals 0.5 into it. So let's do that. Putting t equals 0.5 into this gives you the an estimate for dy dx. So in this case, honestly, just substitute t equals 0.5 into it. No point me rewriting it out. But what you do get is 1.711, and that's your final answer for this question. Pretty difficult question here, but hopefully it made sense to you guys. Yeah, be sure to like the video and subscribe if the video helped. I have a whole A-star level playlist. Be sure to check that out if you'd like to. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.